This one's a real head scratcher. Despite everything we've heard about our universe, there are many existential questions that remain unanswered. It's one of the most compelling questions you could possibly ask, one that humanity has been asking since basically the beginning of time. What's beyond known limits? What's past the edge of our maps? The ultimate version of this question is what lies outside the boundary of the universe? The answer is, well, it's complicated. We don't know if our universe is finite or infinite in extent. We only know that its physical size must be greater than the portion we can observe. We don't know whether our universe encompasses all that exists, or whether it's only one of the many universes making up a multiverse, and we remain ignorant about what happened in the earliest stages of all, in the first tiny fraction of a second of the hot Big Bang, as we lack the necessary evidence to draw a robust conclusion. What is the universe? Is there anything outside of it? To answer the question of what's outside the universe, we first need to define exactly what we mean by universe. If you take it to mean literally all the things that could possibly exist in all of space and time, then there can't be anything outside the universe. Even if you imagine the universe to have some finite size, and you imagine something outside that volume, then whatever is outside also has to be included in the universe. Even if the universe is a formless, shapeless, nameless void of absolutely nothing, that's still a thing and is counted on the list of all things, and hence is by definition a part of the universe. If the universe is infinite in size, you don't really need to worry about this conundrum. The universe, being all there is definitely big and has no edge, so there's no outside to even talk about. Oh, sure. There's an outside to our observable patch of the universe. The cosmos is only so old and light only travels so fast. So, in the history of the universe, we haven't received light from every single galaxy. The current width of the observable universe is about 90 billion light years, and presumably, beyond that boundary, there's a bunch of other random stars and galaxies. But past that, it's hard to tell. The start of it all. Roughly 13.75 billion years ago, our universe came into existence. Very shortly thereafter, primordial light started shooting across the cosmos and spreading throughout the early universe. At this juncture, the universe itself was also expanding. The inflation of the universe slowed after the first initial burst, but since then, the rate of expansion has been steadily increasing due to the influence of dark energy. Essentially, since its inception, the cosmos has been growing at an ever increasing rate. Cosmologists estimate that the oldest photons that we can observe have traveled a distance of 45 to 47 billion light years since the Big Bang. That means that our observable universe is some 93 billion light years wide, give or take a few light years. These 93 some odd billion light years contain all the quarks, quasars, stars, planets, nebulae, black holes, and everything else that we could possibly observe. However, the observable universe only contains the light that has had the time to reach us. A lot more universe exists beyond what we are able to observe. How can the universe be 93 billion light years across if it is only 13.8 billion years old? Light hasn't had enough time to travel that far. Ultimately, understanding this facet of physics is the key to understanding what lies beyond the edge of the observable universe and whether we could ever get there. To break this down, according to special relativity, objects that are close together cannot move faster than the speed of light with respect to one another. However, there's no such law for objects that are extremely distant from one another when the space between them is, itself, expanding. In short, it's not that objects are traveling faster than the speed of light, but that the space between objects is expanding, causing them to fly away from each other at amazing speeds. Encountering the unknown. Despite its strangeness, This first idea is one of the easiest to digest. Astronomers think space outside of the observable universe might be an infinite expanse of what we see in the cosmos around us, distributed pretty much the same as it is in the observable universe. This seems logical. After all, it doesn't make sense that one section of the universe would be different than what we see around us. And honestly, who can envision a universe that has an end? A huge brick wall lurking at its edge? So, in some ways, infinity makes sense, but infinity means that beyond the observable universe, you won't just find more planets and stars and other forms of material. You will eventually find every possible thing. Every possible thing. That means that if it holds true that we follow it to its logical conclusion, somewhere out there, there is another person who is identical to you in every possible way. And there is also you who is only slightly different from you in every possible way. One is an inch shorter, one got hit by a bus 5 years ago and died, one has a missing finger, etc. In fact, this other you may be hearing this article right now. The only difference is that they just picked up their nose while you didn't. Or did you? This notion seems inconceivable, but then infinity is rather inconceivable. Another theory deals with something called dark flow. In 2008, astronomers discovered something very strange and unexpected. Galactic clusters were all streaming in the same direction at an immense speed, over 2 million miles per hour. One possible cause: massive structures outside the observable universe exerting gravitational influence. As for the structures themselves, they could be literally anything. Amazingly huge accumulations of matter and energy on scales we could hardly imagine, or even bizarre warps in space-time that are funneling gravitational forces from other universes. We simply don't know what these massive objects could be. A matter of perspective. When you imagine the universe, you might think of a giant ball that's filled with stars, galaxies, and all sorts of interesting astrophysical objects. You may imagine how it looks from the outside, like an astronaut views Earth from a serene orbit above. But the universe doesn't need that outside perspective in order to exist. The universe simply is. It is entirely mathematically self-consistent to define a three-dimensional universe without requiring an outside to that universe. When you imagine the universe as a ball floating in the middle of nothing, you're playing a mental trick on yourself that the mathematics does not require. Granted, it sounds impossible for there to be a finite universe that has nothing outside of it, and not even nothing in the sense of an empty void, completely and totally mathematically undefined. In fact, asking what's outside the universe is like asking, what sound does color purple make? It's a nonsense question because you're trying to combine two unrelated concepts. The universe has many edges: the edge of transparency, the edge of stars and galaxies, the edge of neutral atoms, and the edge of our cosmic horizon from the Big Bang itself. We can look as far away as our telescopes can take us, but there will always be a fundamental limit. Even if space itself is infinite, the amount of time that's passed since the hot Big Bang is not. No matter how long we wait, there will always be an edge that we'll never be able to see past.